Hello friends, welcome to the video lecture series on digital image processing. I am Dr. Dafda, and in this 68th video class of DIP, we will understand one other image representation technique, namely boundary segments in digital image processing and its implementation in MATLAB. Starting with the name, as the name suggests, boundary segments means we will be segmenting or we will be partitioning boundary. And why do we segment the boundary? To reduce the complexity of the boundary representation and to simplify the description process. Okay. So let us start. And as we understood earlier also, these are the main steps of image processing from which currently we are learning image representation. So boundary segment is a type of image representation technique in which a boundary is decomposed or partitioned into segments, and when it is used when the boundary has one or more concavities, that is curve that carry shape information. Concave curves means the curves that are bending inside, right? What is the aim of boundary segments? The aim of boundary segments is to partition an object boundary into segments or parts. And see, this decomposition of the boundary into segments is also very useful. It reduces the boundary complexity and it also simplifies the description process. So when a boundary contains major concavities that carry shape information, it can be worthwhile to decompose it into segments. Boundary segment is useful to extract information from the concave parts of the objects. So a good way to achieve the information from the concave parts is to calculate the convex hull of the region enclosed by the boundary. And this convex hull we have already understood in our video lecture number 57, some basic morphological algorithms. And in that video class we understood that the convex hull is the set of smallest convex polygon that contain all the points, and this convex hull does not have any concave part like this. Okay, when we find the convex hull, the concavity is removed. Say for example, this is our object which is a set S, and this is the object boundary of this set S. Then what is convex hull? Convex hull is this gray color complete set which does not have any concave part. So the convex hull of an arbitrary set S is the smallest convex set containing S. So this convex hull we will call H. Then the set difference between H and S is called the convex deficiency D of set S. So D is equal to this complete H minus S, that will be this shaded region. So convex deficiency is the shaded region D. So what is convex deficiency? Convex deficiency is the shaded region D. Then how to segment the boundary? The boundary can be segmented by following the contour of S. We'll follow this S and marking the points at which the transition is made into or out of the component of the convex deficiency D. So here we are going out of convex deficiency D. So this is one of the segmented point. Here we are coming inside the convex deficiency. So this is second segmented point, or we can say the segmentation point. Here again we are going out. So this is one other segmented point. Here we are coming in. So this is one segmented point. Similarly, this is one segmented point. This also is one segmented point. This is one segmented point, and this also is one segmented point. So using these segmented points, we are segmenting or partitioning the boundary. This is one partition. This is second partition, this is third partition, fourth partition, and so on. And that partitioned or segmented boundary is shown over here. So this process is known as boundary segments. So what are the advantages of this boundary segments? First advantage is that this scheme is independent of region size and orientation. And second advantage is that it can be used to describe a region and its boundary. So it can be used for region description. But there is also one disadvantage. See, in practice the digital boundaries tends to be irregular because of digitization, noise and variations in segmentation. So it is sensitive to noise and therefore smoothing may be required. So rather than removing these irregularities in post-processing, normally we smooth the boundary prior to segmentation or convex hull calculation, you can say. And second technique, which is more reliable for this noise removal, is to use polygonal approximation prior to finding the convex deficiency. And this polygonal approximation we have already understood in the previous video class. I hope it is clear. Let us implement this boundary segments in MATLAB. You can find the MATLAB code in the description box. That is all for this video class. Thank you very much.